this lesson is for my 7th grade math students who are just encountering algebraic expressions, and we're just learning how to simplify. We started out really basic. We were learning how to add and subtract like terms. So today I'm just showing you a couple of like terms that need to be combined in different ways. So I'll start with this first example. And again, by the end of this lesson, my hope is that you know how to combine like terms, and you also know how to sort between unlike terms to combine the things that can be simplified. We get down to the simplest form possible. If we take a look at this first problem, I notice all of the variables match. This is really a good thing. We have some like terms happening here. So I really want to combine them all. I also notice that I'm really just applying some integer rules. No decimals, no fractions to deal with. Oh, but hold up. I see a coefficient here of 3 and a coefficient here of 5, but I don't see a coefficient in front of my a. It might be a good idea to show what we call an implied coefficient. It might be a good idea to show how many a's I have here when working with this model, okay, or this example. So let's take this first piece and just work in order from left to right. With addition subtraction, I hope you remember in PEMDAS we can move from left to right. Well, this really says 3 a's take away 5 a's. Another way of seeing this might be to add the opposite, or change a minus to a plus, change the sign of next. Well, if I had 3 a's and I took 5 a's from you, you owe me some. That's a negative 2a, isn't it? You went farther into the negatives. You took away more than you had. Next, we could bring down this idea of one group of a, one whole a. Well, I can still combine these. They still have like terms. They're all comparing to a full bar that's worth a, an unknown value. So we'll just keep it as an a variable here. And I'd say, what's negative 2 plus a positive 1? Well, if you remember, you're really going to apply different signs subtract. So you're going to end up with a negative 1. And remember, all of these are comparing a's. So negative 1a looks like an okay answer. Hey, I'm happy. You got there. This is not a final answer. It's not bad. It's a good start. But we've talked in class about how to show this in a simplest form. We take out unnecessary notation. So do you see something that we don't need to show? Can I get rid of the negative? Would it have the same value? No, definitely not. Could I get rid of the variable? Would that have the same value? No, definitely not, because this is representing a multiplication times an unknown value, isn't it? So the only other thing to get rid of would be the 1. Is that a possibility? Could I rewrite this? Is this the same as a negative group of a? Oh, it absolutely is. So this is really the final answer that I want to start pushing students to see. Again, it's just a little more algebraic in its response. It's not right or wrong either way, but again, if you're looking for the purple star today, this is where I want to see you. Let's take a look at our second example. Notice all my variables match. They all have the same identity, the same label. So B's can go with B's, can go with B's. It's a lot of B's apparently. Let's go ahead and work in order from left to right. We've only talked about simplifying with addition subtraction, so we really can follow PEMDAS in order from left to right now. Can you shut that? All right, so we'll try that again. I have 1 8/10 b that I'm adding to 4 whole b's. Well, remember in decimal addition, you really have to line up those decimals, don't you? 4 wholes plus 1 whole would get me 5 whole b's, plus that 8/10 of a b. So 8/10 goes at the back here. And remember, these are all variable terms. I need to make sure that his identity is there. I see a lot of students trying to remove that, but it's kind of dangerous because soon we're going to see a combination of variables, and we have to make sure we know which gets which label. All right, I'll bring down the other pieces that I haven't used yet, taking away 9/10 b. Well, here's a subtraction that I can handle in order from left to right. I can really put these together. I could use different signs subtract, or in this case, it looks like the larger or farther number, 5.8, comes first. So off to the side, so I don't ruin my pizza model, I might go ahead and show you a quick subtraction. Well, 8/10 take away 9/10 would be difficult to do unless I do a little regroup here. So 18 take away 9 here in the 10th place gets me 9/10. And I get to bring down my decimal. This is decimal subtraction. So decimals come straight down. And 4 take away 0 is really 4. So I'm going to get an answer of 4 9/10. But be careful. Over here in my work, I removed the b, right? The whole bar of b is what we're comparing to. Well, these are still values that are related to b. I need to still show in terms of b. This is a final answer. And notice sometimes I will end up with a negative result. If I had taken away more than I had started with, I could have a negative answer here, like in the last one. Well, in this case, the farther number was positive, so I'm good to go. The next thing I want to show you is a little more complex. And I saw students kind of excited and likewise kind of moan and groan when they saw this the other day with me. We still want to combine like terms, but not all of these are alike. So we really want to dig in here carefully and figure out what can go together. I have a couple different strategies that we can try here. The first one I'm going to show you is what I call a column strategy. So first I go through and I figure out what kind of columns do I need. Well, I need M's. These M's seem to go together. And I also need some N's. N's go together. They're like terms. So I'm going to make a column for M. I'm going to make a column for N, and we're going to try combining. Let's see what we have. So what I'm going to record here is the coefficients. The coefficients that came from the variable M terms. So the first coefficient I see is 7/8. So I'm going to take the 7/8 and record it here. It's an M. Next up, if I go in order from left to right, just so I don't miss any terms along the way, I see 1/2 N. I might record this 1/2 in the N column because, again, he has an unlike term. He doesn't match the M's. Oftentimes talking about going to the restaurant for Thanksgiving dinner. Not that I do that, but some people might. And you usually sit with family. So M's sit with M's and last name N's sit with N's. That's kind of how it would work. Take a look at this next one. Oh, it's an M term, so I know that this coefficient of 3 can go with the M's. That sounds great to me until this. I notice that there's a subtraction here. You do have to be careful. It might be a wise idea to show adding the opposite. That really makes this coefficient a little bit special, doesn't it? It's not a positive 3, it's a negative 3M. And last but not least, I want to combine an N with the N table. I want to put the N's together because they're like terms. So we might want to show an implied coefficient of 1 sitting here. And I'm going to add 1 to the N's. I'll be honest, I've never really tried this column strategy with fractions. I'm not sure if I like it. Let's see what happens. Well, because I have different signs here, I'm going to have to use different signs to subtract. So I'm really going to have to say, well, 3 take away 7/8. If I had a 3 taking away 7/8, I know I'm going to be left with 2 whole. So 2 whole somethings, right? But how much more would there be? Well, 7/8 plus 1 more 8 would get me that extra whole part. So it looks to me like I'm going to get a negative, because the negative was a farther number, a negative 2 1/8. Would that check out? If you added 7/8 back to this, would you be up to 3? Absolutely. So I think we're good here. And again, I kind of used different signs to subtract. I kind of used that in my head, didn't I? How about this one? These are both positives. This is really a positive 1/2 and a positive 1. There's no different signs. There's no subtraction and regrouping here, is there? I can just combine them. What's 1 plus 1/2? 1 and 1/2. This isn't bad, except I sure hope you notice something dangerous. This is algebra land, and you almost forgot to give these families their identity. These terms, this should actually be an M term, and 1 and 1/2 should actually have an N with it. I'll also caution you, I see students putting these variables in denominators and all over the place. For our purposes, until we talk a little more deeply about it, just make sure that it goes with the whole quantity. It goes next to the fraction. Or if you decide to do something crazy, it can go in the numerator. But let's not go beyond that. This is almost a final answer. I just go ahead and write it out here, negative 2 and 1/8 M. And I'm adding, I'm trying to put these together as much as I can. 1 and 1/2 N. This is okay. It's not bad at all. But let's be honest. Pretty soon we're going to be talking about algebra land and equations, and we're going to need to see slope. We're going to need to see improper fractions. So there's another good way of showing this answer. It looks like I could turn this into an improper fraction with 8 times 2 and adding 1. 8 times 2 is 16 plus 1 more makes 17. Keep your denominator. This is a negative 17/8 M. And on the other term here, I can do the same strategy. Multiply, add, and keep is what we call it for shortcut. And I would say 2 times 1 is 2 plus 1 more makes 3. Looks like I get a positive 3/2. And this is an N term. This is as close as we can get to a final answer. I also want you to notice one more thing. It would be okay if you switched up your columns. If the N's came first, the M's came next. That wouldn't really be a problem for me, although you need to know. Final answers go in ABC order when we can. So ABC order is kind of what we're thinking about with our variable terms right now. So this is as close as we can get. This is probably where we want to see you go. All right, we have one more example, and oh, this one gets more challenging, because if you notice, I have even more going on here. Let's dig in a little bit. Does anything match this x term? Oh yeah, there's another x minute at the back. Does anything match this y term? Oh yeah, there's some more y terms right next to him. But this one kind of is left out. What's going on with this term? He doesn't have any variables with him. In fact, he's a decimal. I'll give him a different code. I'll show you that he gets his own situation here, doesn't he? In fact, we learned a good name for him the other day. These are called constants. Oops, constants. Let me write that correctly for you. My student said kind of like a loner. Yeah, he's kind of like a loner. He doesn't really have a name or an identity. He's kind of hidden here, isn't he? Okay? So let's go ahead and see if we can combine some like terms. Looks like I'm going to combine some x's. I'm going to combine some y's. And I'm also going to combine some constants. So we'll just try this column strategy one more time when I'm dealing with some decimals and different things in here and see how it goes. So I like to grab the coefficients, and I like to go in order from left to right so we miss nobody in the line of restaurants, right? So here we go. First comes 5x. The coefficient is 5, and he goes to the x table. There you go, sir. 5. Enjoy your dinner. If you take a look at this next term, it says 1 2/10 y. Well, I'll take the coefficient, even if it's a decimal. This 1.2 goes with the y's, guys. 1.2. There's your table. Enjoy. Oh, good. Here comes another y. At least he has company. So I want to record the coefficient, but you should really be careful in this situation. What do you notice here? This guy looks a little grumpy. In fact, he doesn't look very positive at all. If you change a minus to a plus, change the sign of next, we could treat this as a -2. This is really a -2y. And I might even put a decimal point and a 0 at the back, just because I know I'm going to have to align my decimals here in a minute. Just food for thought. All right, thank you. Welcome to your table. And here I have this constant. Well, he doesn't have any variables. He sure doesn't go with the X-Men. He can't sit with Wolverine. He doesn't go with the wise guys. He's not funny enough. But he could sit with the constants. Here he goes. 0 and 6/10. I have one more to add here, or to combine, I should say. We're combining like terms. So here I have this term 8x, but caution alert. It's not a positive 8 at all, is it? We're really taking it away. So another way of showing that is adding the opposite. I want to take away 8x here. So I'm going to take the coefficient of a -8 and record it with the x-men, or the x table, or the x column. All right, I think we're ready. Let's go ahead and try to combine these, see what we get. So I'm treating it kind of like 3 separate pieces. The x's combined, the y's combined, the constants combined. Well, 5 take away 8. Oh, I took away more than you had. You're going to end up with a -3. But be careful, those are x-men. They still have an x for their identity. Some students like to show these x's all the way down, just so that they don't drop them along the way. That's a good idea too. How about here? Here I have 1.2, or 1 2/10, and I want to take away 2 wholes from you. Well, this is a different sign subtract situation. You could show your y's back here. And you'd really have to do a flip-flop if you wanted to do the regroup or subtraction. But I happen to know that 1 2/10 plus 8/10 more would get me 2. So I know that I'm going to be missing 8/10 y. If you want to show the regroup off to the side again, you just take the -2 and 0/10 and the 1.2 and subtract them down here with a little regroup. You can do that also. How about my constants? Well, he really is a loner this time. There are no other constants. Sometimes there will be, but I guess I didn't make any in this problem. So there's nothing to combine with him. He is just a 0 and 6/10. And does he get a variable? Do I write constants next to him? Do I give him an x or a y? The answer is no. This looks pretty good. Well, the last thing you would do to show me that we're trying to combine these terms is show me some addition. This looks great. This is a good answer. This is a good spot to be at this point of the game. Notice I'm also in ABC order, X before Y in the alphabet. And the last thing that we usually show are constants. So this is a pretty decent order. Now, I did challenge my students the other day. Some of you were up for the challenge. You notice that there's something we could do for final answers. Sometimes we take off unnecessary notation. Well, guess what? There's some unnecessary notation here. What is the one thing that we could get rid of that would still keep the same value? We haven't really learned this yet, so this is food for thought. Take a look right here. Adding the opposite. Whenever I see this combination of adding a negative, this combination, like if I could imprint this in my mind, it really could be turned into a more simple form. where did that come from? What's another way of saying add the opposite? Isn't that the same as saying subtract? Oh, that's it. I know that I could rewrite this. I could say, I still have negative 3x, but I'm just going to take away 8/10 y. And at the back, I'm going to add on 6/10. And remember, that's a constant, so no variable for him. This is a stronger algebraic answer. It's probably a little more common to what you'd see in multiple choice tests, probably what you'd find online, and this is where it comes from. This combination of adding an opposite. We use it this way when we're talking about combining like terms, when we're doing all the math steps along the way. And then the final answer, we simplify it. We say, oh, you can have your subtraction back if you like. I hope that out of our 4 examples today, you had an opportunity to differentiate between like terms and unlike terms. So one of your targets today was to be able to combine those terms that are alike. I hope you also had a chance to identify some ways to make your answers final answers, like moving to maybe a simplified form, removing some unnecessary notation, and maybe making sure we're in ABC order. ABC order was important to us today. And even showing improper fractions, but making sure they're in simplest form. That makes for a good final answer also. And we did some decimal review, so again, we're really applying our integer rules, our decimal rules, and even some fraction rules along the way. This is really enough to cover for now. This is kind of what we're going to be looking at a quiz over this week before we go on break. So give it a try. There are definitely tons of practice problems within your textbook, and you can access that online too if you need some extra help.